Hello student, we have completed the differentiation first chapter for the M2 and I hope that you have done the full practice of all the exercise 1 to 5 and also the miscellaneous. You can find out the derivatives of by using with the help of the chain rule, with the help of the logarithmic function and the derivatives of the inverse, parametric and higher order derivatives. And now we will start the new topics, that is application of the derivatives. Very interesting. Also, it's very tough type of the problems are also there. But if you do the hard work, too much hard work, then you will be the master in the application of the derivatives. I'd explain each and every examples in a very simple way. I hope that you will understood all the problems, whatever that I am explaining here. Some of the students are doing their regular studies. Their comments I read, and with the help of I am starting today the application of derivatives. Very interesting topics. Now let us start application of the derivative. Let us study what we are learning in this chapter. That is the application of derivatives to tangents and the normal. This is the first very interesting topic. The second is derivative at a rate measure. It depends on the physics, that is a rate measure. Approximations, that's a very interesting. Rolle's theorems and Lagrange mean value theorem, that is LMVT. Increasing and the decreasing function, very interesting. And the last is maxima and minima. If we have the very tough problems, and it is very interesting to solve these problems with help of our geometry and the knowledge of the derivatives. Now introduction. In previous chapter we have studied the derivatives of various functions such as composite functions, that is function in function, inverse trigonometric functions, that is sine inverse, cos inverse, logarithmic. And we cannot solve the differentiation by using our regular method. That's why we take the log on both sides and differentiate. And also the relation between the derivative and the slope of the tangent. In this chapter, we are going to study various applications of differentiation, such as first is application, that is the geometry, rate measure, approximations, Rolle's theorem, and Lagrange mean value theorem, LMVT. And the last is maxima and minima, increasing and the decreasing functions, and the last is maxima and the minima. Now let us learn application of a derivative in geometry. Let f of x is equals to y be a continuous function of x representing a curve in xy plane, and px1 x1 y1 be any point on the curve. That is y is equals to f of x. This is the curve pxy x1, y1 is a point on the curve. If we find out its a derivative at the point x1, y1, that is f dash of x at point x1, y1, represent a slope is called, it's also called the gradient of the tangent. To find out the equation of the line, we required point on the line and also it's a slope. Therefore, to find out the tangent to the curve at a given point, we first differentiate that equation and find out the value at that point x1, y1. That's why you will get the slope or the gradient at that point, and you can find out the equation of the tangent to the given curve. The normal is perpendicular to the tangent, a line which is perpendicular to the tangent. Hence, the slope of the normal is a minus and reciprocal of the slope of the tangent will be the negative of the reciprocal of the slope of the tangent, that is at the point. Let m and m dash be the slopes of tangents and normal respectively. Then m is equals to dy by dx at the point x1, y1, and m dash is equals to minus 1 upon dy by dx at the point x1, y1. Means that the slope of the normal and the tangents are minus and reciprocal of each other. Now the equation of the tangent is nothing but the equation of the line, that is with the help of the slope point form. This is the slope point form. It means that slope means what? M is there and point is that x1, y1. This is the equation of the line in slope point form, and that line is a tangent to the given curve at the point x1, y1, and its equation is y minus y1 is equals to m in bracket x minus x1. Tangent is nothing but a line. Its equation is just similar to the equation of the line, and we know the slope of the line and point on the line. Then we can find out the equation of the line with the help of the slope point form. Y minus y1 is equals to m in bracket x minus x1. And equation of normal at p x1 y1 is given by y minus y1 is equals to m dash in bracket x minus x1. Now let's see the illustrative examples, that is solved examples. In board exam, the solved examples are very important. Find the equation of the tangent and the normal to the curve at the given point on it. That is y is equals to 2x cube minus x square plus 2 at the point 1, 2. Now we want to find out the equation of the tangent and the normal. First differentiation, find out dy by dx. What is dy by dx? That is a 6x square minus 2x. And substitute x is, that is 1 upon 2 and not necessary for the point 1. Put the value of the x 1 upon 2, you will get the gradient or the slope of the tangent at that point. Then apply the slope point form, which is y minus y1 is equals to m in bracket x minus x1. Now let us find out. Y is equals to 2x cube minus x square plus 3. Now differentiate this with respect to x. Dy by dx is equals to 6x square minus 2x. Therefore, the slope of the tangent at p at x 1 upon 2 and 2. That is m is equals to, substitute its a value. That is 6. That is a 6 in bracket 1 upon 2 bracket square minus 2 into 1 upon 2. That is m is equals to 6 into 1 upon 4 minus 1. That is a 3 by 2 minus 1. That is equals to 1 upon 2. This is the slope of the tangent. Now, the slope of the normal is a minus and reciprocal of that. Its slope is a minus 2. Now, the equation of the tangent is given by y minus y1, that is y minus 2 is equals to 1 upon 2 in bracket x minus 1 upon 2. Now, evaluate this equation, that is that 2y minus 4 is equals to x minus 1 upon 2. That is a 4y, that is a multiplied again the given equation by 2, then you will get 4y minus 8 is equals to 2x minus 1. That is a 2x minus 4y plus 7 is equals to 0. This is the equation of the tangent to the given curve. Now the equation of the normal is given by, that is the y minus 2 is equals to minus 2, which is the slope of the normal in bracket x minus 1 upon 2. And now simplify this equation. That is a 2x plus y is equals to 3. Therefore 2x plus y minus 3. This is the equation of the normal. And these are the equations. Now the second, x cube plus 2x square y minus 9xy is equals to 0 at the point 2, 1. Now differentiate this example with respect to x. Now this is the differentiation of which type? This is implicit type of the derivatives. Implicit type function this is. Now x cube, derivative of x cube is a 3x square. And to find out the derivative of x square into y, and to find out the derivative of x into y, apply the product rule. Now let us start. That is 3x square plus 2 in bracket 2xy plus x square into dy by dx minus 9 in bracket. The derivative of x is 1 dot y plus x into dy by dx, that is equals to 0. Therefore 3x square plus 4xy plus 2x square into dy by dx minus 9y and the minus 9x into dy by dx is equals to 0. This is the simplification. Now collect the terms of the dy by dx. Take the dy by dx as a common, then in bracket you will get 2x square minus 9x is equals to 9y minus 3x square minus 4xy upon 2x square minus 9x. Now we want to find out the gradient at the point 2, 1. Substitute the value, that is a 9 into 1 minus 2 into 2 square minus 4 into 2 upon, that is a 2 into 2 square minus 9 into 2. Now find out the values. This is the calculation. That is m is equals to 11 upon 10. In the textbook, the point has been changed. We have taken the tangent at the point 2 and 1. That is at the starting point. That is he has given 2 and 1. And when he solve the examples, he take the 1 and 2. That's why answer is different. It doesn't matter. But our process to find out the method to find out the equation of the tangent and the normal is important. Whatever that is given, that may be the correction. That is equation of the tangent y minus y1 is equals to m in bracket x minus x1. Y minus 1, that is equals to 11 upon 10 in bracket x minus 2, and simplify this equation. Then you will get the equation of the tangent. Now this equation is different from the textbook. You can understand this. That is point they have taken is a different one. Actual point is 2, 1, but they have taken 1, 2. This is the equation of the tangent. Next is equation of normal. Y minus y1 is equals to minus 1 upon m in bracket x minus x1, and substitute the values. Therefore, you will get that is a 10x plus 11y is equals to 31, and this is the I had written there. I had taken the point 2 comma y. The point is 2 comma y. Therefore, the answer for the type 2 is different. Now the next is this is differentiation, just like it is a parametric, that x is equals to 2 sine cube theta, y is equals to 3 sine cos cube theta at the point theta is equals to pi by 4. Now the derivative. Now their points. First of all, we find out the values of x and y. That is, we want to find out the equation of the tangent and normal. We require the point P x1 y1. That's a 2 sine cube pi by 4 is equals to 2 into 1 upon root 2 bracket square. That is a 2 into 1 upon root 2 bracket square means what? 1 upon 2 root 2. And then simplify. You will get its value. That is 1 upon root 2, x is equals to, and y is equals to 3 cos cube pi by 4. Therefore, here you will get, that is 3 upon 2 root 2. This is the point. That is the point is 1 upon root 2, 3 upon 2 root 2, and bracket complete. Now, we'll find out the slope of the tangent and normal at the point 1 upon root 2, that is at the point pi by 4. Dx upon d theta. This is the parametric differentiation. That is x is equals to 2 sine cube theta. You must know that is a 6 sine square theta into derivative of sine theta, which is a cos theta. Also, dy upon d theta, dy by d theta, that is a 9 cos square theta into derivative of cos theta is a minus sine theta. That is a dy by d theta is upon dx upon d theta is equals to minus 9 sine theta into cos square theta upon 6 sine square theta into cos theta. That is minus 3 by 2 cot theta. Now the equation of the tangent. The equation of the tangent y minus y1 is equals to m in bracket x minus x1. That is y minus 3 upon 2 root 2 is equals to minus 3 by 2 in bracket x minus 1 upon root 2. And now simplify this. That is a minus 3x upon 2 plus 3 upon 2 root 2. And now simplify this. Therefore, you will get y is equals to, that is y is equals to minus 3x upon 2 plus 6 upon 2 root 2. And that's we will simplify it. That is 3 by 2x plus y minus 3 upon root 2 is equals to 0. 3x plus 2y minus 2 root 2, that is multiplied. Now the next is equation of the normal. Y minus y1 is equals to minus m in bracket x minus x1. Substitute the value. Then simplify this equation. That is 3 by 2 into x. 3 by 2 into 1 upon root 2. That is a minus 2 upon 3 root 2. 2x upon 3 minus y plus 3 upon 2 root 2 minus 2 upon 3 root 2. That's equals to 0. Now simplify this. by making the cross multiplication. That is 2x upon 3 minus y. If you perform the cross multiplication, that is a 9 root 2 minus 4 root 2 upon 6 root 2 into root 2, that is a 2. Therefore 2x upon 3 minus y, 5 root 2 upon 12, that is 8x minus 12y plus 5 root 2, that is equals to 0. And this are the again by simplification, that is a 4 root 2x minus 6 root 2y plus 5 is equals to 0. Next is find point on the curve given by y is equals to x cube minus 6x square plus x plus 3, where the tangent is parallel to the line, which is y is equals to x plus 5. Here we want to find out the point. At which point, if we draw the tangent to that curve and that tangent is parallel to this line, means what? As these two lines are parallel, this is the application of geometry. Now these two lines are parallel, their slopes are equal. That it means that if we differentiate the given curve, then its value is equals to the value of this line. What is the slope of this line? It is of the form y is equals to mx plus c, and therefore slope is 1, equal to equals to 1, and so on. Now see this. Equation of curve is y is equals to x cube minus 6x square plus x plus 3. Now differentiate this with respect to x. Therefore dy by dx is equals to 3x square minus 12x plus 1. The given tangent is parallel to y is equals to x plus 5, whose slope is 1, and that's why the slope of which is nothing but the slope of the tangent, that is the dy by dx is equals to 1, and that is equals to 3x square minus 12x plus 1. Now solve this, that is a 3x square minus 12x is equals to 0. Now factorize this, take 3x as a common, then in bracket you will get x square minus 4 is equals to 0. That is x minus 4 is equals to 0. That's why you will get the point that x is equals to 0 or x is equals to 4. Now when x is equals to 0, find out the value of y, that is equals to 3. And when x is equals to 4, then substitute x is equals to 4 in that equation of the curve, then you will get minus 25. Therefore the required point on the curve are 0, 3 and 4 minus 25. These are the required points. Now we'll see the next topics, that is the derivative at a rate measure. These problems are again very simple. This is the nothing but the application of physics also here. A stone is dropped in a quiet lake. शांत तळ आहे त्याच्यामध्ये काय स्टोन ड्रॉप केलेला आहे, and waves in the form of the circle are generated. The radius of the circle's waves increases at the rate of 5 cm per second. What is here? A stone is dropped in white lake and the waves in the form of the circles are generated. Waves are generated. The radius of the circular waves increases at the rate of 5 cm per second. म्हणजे एका सेकंदाला 5 सेंटीमीटर ती radius त्या सर्कलची वाढत जाणार. That is increasing at the rate of the 5 centimeter per second. It means that at first second it will be 5, at second it will be the 10, and in this way it is increasing. At the instant when the radius of the circular wave is 8 centimeter, how fast the area enclosed is increasing. How fast the area enclosed is increasing. Now we have given that is R is 8 when the radius is. Let capital R be the radius and capital A be the area of the circular wave. A is equals to pi r square. Now differentiate this with respect to t. Now dA upon dt. That is a dA upon dt. That is equals to. Now this is a that doesn't contain that is a t. Therefore we'll apply here the chain rule. dA upon dt is equals to pi. That is a 2r into dr upon dt. We differentiate there. Now what is the dr upon dt? The radius is increasing at the rate of 5 centimeter per second and substitute value. Thus when r is equals to 8, from 1 we substitute the value of r, that is a 2 pi into 8 into 5, which is the rate. Substitute the value, then you will get 80 pi. That's why the area is increasing at the rate of 80 pi square, whatever that square centimeter. Hence, the radius of the circular wave is 8 centimeter. The area of the circular wave is increasing at the rate of 80 pi centimeter square per second. Now the second example. The volume of a spherical ball is increasing at the rate of 4 pi cubic centimeter per second. Find the rate at which the radius and the surface area are changing. When the volume is 288 pi centimeter cube. Now see this again problem. Read the problem very carefully. The volume of a spherical ball is increasing at the rate of, that is we have given dV upon dt. Find the rate at which the radius, means we want to find out dr upon dt. Also we want to find out surface area changing. That is the surface area means what? ds upon dt. That's we want to find. When it's a volume is that is a 288 pi cubic centimeter. Now let us start. Let capital R be the radius and S be the surface area and V be the volume of spherical ball. V is equals to 4 upon 3 pi r cube. First, it's the volume of the sphere. Now differentiate this with respect to t. That is 4 upon 3, 4 pi upon 3. That is the derivative of r cube. Its value is given, that is a 4 pi. Its rate is given, dV upon dt we have given that. That is 4 pi is equals to 4 pi upon 3. Now the derivative of r cube, that is a 3r square into dr upon dt. That's why we will get the value of dr upon dt. We have given that the dr upon dt is a 4 pi cubic centimeter per second. Therefore dr upon dt is equals to 1 upon r square. When the volume is a 288 cubic centimeter, that is a 4 pi r cube is equals to 288 pi. Then what is radius? That is r cube is equals to 216. Therefore, r is equals to 6. Therefore, from 2 we get dr upon dt is equals to 1 upon 36. This is. So the radius of the spherical ball is increasing at the rate of 1 upon 36 centimeter per second. Double C is added there by mistake. Now S is equals to, what's the surface area of the sphere? S is equals to 4 pi r square. Now differentiate this with respect to t. ds upon dt is equals to 4 pi ddt of r square, which is the 2r into dr upon dt. And overall the multiplication is the ds upon dt is equals to 8 pi r into dr upon dt. So when r is equals to 6, ds upon dt at r is equals to 6 is 8 pi 6 into 1 upon 36. That is equals to 4 pi upon 3. Therefore, the surface area is increasing at the rate of 4 pi upon 3 centimeter square per second. Then you can see this here. This is perhaps just that is the dr upon dt is 1 upon r square. When the volume is a 288 pi cubic centimeter, then you will get the value of r. That is therefore dr upon dt is equals to 1 upon 36, and that's why this is only the radius is increasing, that is 1 upon 36 centimeter per second. Double C is there by mistake. S is equals to 4 pi r square. Differentiate it. At r is equals to 6, therefore ds upon dt is equals to 4 pi upon 3. Therefore, the surface area is increasing at the rate of 4 pi upon 3 centimeter square per second. Now the next problem is water being poured at the rate of 36 meter cube per second into a cylindrical vessel of base radius 3 meters. Find the rate at which water level is rising. Let capital R be the radius of the base, capital H be the height, and V be the volume of the cylindrical vessel. Now read the second problem. Water is being poured at the rate of 36 meter cube per second. या वेगाने ती टाकी भरली जात आहे. In a cylindrical vessel, the base radius is 3 meter. Base radius is 3 meter. Find the rate at which the water level is rising. It means we want to find out dH upon dt. This we want to find out. Now see this, how it is. Let capital R be the radius of the base, capital H is the height, and V be the volume of the cylindrical vessel. At any time, these R, V, H are the functions of the T. These are changing. R, radius, volume, and the height are the functions of the T's. They are changing with the time T. Therefore, very interesting. That is application of the derivatives. These problems are very nice. That V is equals to. Now, what is the volume of the cylinder? It's a V is equals to pi R square into H. Substitute value R is equals to 3. Then you will get V is equals to 9 pi H. Now differentiate this with respect to T. dV upon dt is equals to. That is a dv upon dt is equals to 9 pi into dh upon dt. Therefore, dh upon dt is equals to 1 upon 9 pi. Now we want to find out the value of the dh. At what rate the level of that cylinder is, that is the dh upon dt is equals to 1 upon 9 pi into dv upon dt. Given that dv upon dt is equals to 36 meter cube per second, we have given this and substitute that value. That is, from 1 we get dh upon dt is equals to 1 upon 9 pi into the value of dv upon dt, that is equals to 36, and simplify it. That is equals to 4 upon pi. Water level is rising at the rate of 4 upon pi meter per second. This is the water level. Now you can see this also here. Very nice problem. Now next is a man of height 180 centimeter is moving away from a lamp post at the rate of 1.2 meters. He is living away from the lamp post per second. If the height of the lamp post is 4.5 meters, find the rate at which his shadow is lengthening. The tip of the shadow is moving. Now see this first. That is AOB. This is the triangle. This is the lamp post. AO is the lamp post. MN. This is the man. Now see this. The Y is the distance. That is the OM is the Y distance of that man from the lamp post. And X, that is equals to MB, which is the shadow of the man. Let OA be the lamp post, MN be the man, MB is equals to X, be the length of the shadow, and OM is equals to Y, be the distance of the man from the lamp post at the time t. Given that man is moving away from the lamp post at the rate of 1.2 meter per second. X and Y are the functions of t. They are changing with the time. Therefore, x, y are the functions of the t. Now, what is the dy by dt? That is, we have given that the dy by dt, that is a man of the height 180 centimeter is moving away from the lamp post at the rate of 1.2. That we have given, that is the dy by dt. Its rate is given, that is the 1.2 meter per second. The rate at which the shadow is lengthening. Now the shadow is MB. Its a length, it's a distance of that MB is equals to, that is the distance of this MB is equals to X. Therefore, the dx upon dt, see this here, dx upon dt, that's a shadow is lengthening, that is the dx upon dt, that's what I want to find out. B is the tip of the shadow and it is at a distance of x plus y. Yes, it's clear that this distance is x plus y. X plus y. This is the distance. Now the next is now solve this. That is x upon. Now that two triangles are similar. Okay. The given two triangles are similar. Therefore, x upon 1.8 is equals to x plus y upon 4.5. Now see this. X upon, this is here, x upon 1.8. And what about x plus y? X plus y upon 4.5. Because the height of this lamp post is 4.5. And the man is the height of 180 centimeter. Therefore, it is converted in the meter, and which is 1.8. Therefore, x upon 1.8. Now again, these two triangles are similar. Which are the triangle? That is a M, N, B, O, A, B. These two triangles are similar. Therefore, Mn upon x is equals to AO upon x plus y. And with the help of this, we can find out the value of x in terms of y. That is x upon 1.5 is equals to x plus y upon 4.5. X upon 1.8 is equals to x plus y upon 4.5. And solve this. Then you will get x is equals to 2y upon 3. Now differentiate this. We want to find out the rate at which the shadow is lengthening. जसं जसं या लॅम्प पासून आपण लांब जाणार तसं तशी आपली सावली कशी होणार मोठी मोठी होत जाणार. That's we want to find out. Therefore, dx upon dt is equals to 2 upon 3 dy upon dt. Substitute the value of dy by dt, which is 1.2, and after calculation, you are getting the 0.8 meter per second. The rate at which the tip of the shadow is moving. Now the tip of the shadow means what? This tip is moving. That's we have to consider x plus y and their differentiation. Therefore, ddx of x plus y is equals to dx upon dt plus dy upon dt. Dx upon dt is a 0.8, dy upon dt is a 1.2, and if you add it, then you will get 2 meter per second. That's why the shadow is lengthening at the rate of 0.8 meter per second, and the tip of its tip is moving at the rate of 2 meter per second. Fix. To differentiate this, dx upon dt is equals to 2 upon 3 into dy by dt. That is equals to 2 upon 3 into 1.5. The calculations comes 0.8 meter per second. And next is the rate at which the tip of the shadow is moving given by ddt of x plus y. That is the dx upon dt plus dy upon dt. Substitute the values. Dx upon dt, it's a shadow is a lengthening, and dy upon dt, that's we have given 1.2, that is a 2 meter per second. Therefore, the shadow is a lengthening x plus 1 at the rate of 0.8 meter per second, and the tip of the shadow is moving at the rate of 2 meters per second. Now the next is a velocity, acceleration, and jump. This we have also in physics. If s is equals to f of t, means what? S is the distance. It is a function of the time. It's a variable is a t. S is equals to f of t is a displacement function of a particle that moves, it's a displacement, that moves along a straight line. F dash of t is the rate of change of the displacement s with respect to the time t. In other words, f dash of t is the velocity. If we find out the first derivative, then we get the velocity. If you find out the second derivative, you will get the acceleration. In other words, f dash of t is the velocity of the particle. The speed of the particle is absolute value of the velocity. That is mod of f dash of t. The rate of change of velocity will, with respect to time, is called the acceleration of the particle, denoted by a bracket t. Thus, the acceleration function is a derivative of the velocity function and is therefore the second derivative of the position. Means what is position function? S is equals to f of t. Then a is equals to dy by dt, that is the d2s upon dt square, second derivative, that is called the expression. That is a in bracket t and v dash of t, that is s double dash, that is the second derivative. This is the application of the second derivative. Let us consider the third derivative. The third derivative of the position function s is equals to f of t of an object that moves along a straight line. S triple dash of t is equals to v double dash of t is equals to a dash of t is a derivative of the acceleration. It's a derivative of acceleration function and is called the jerk. Thus, J is equals to dA upon dt d3s upon dt cube, and hence jerk J is the rate of change of acceleration. Now the illustrative examples. Now see this example. First example. A car is moving in such a way that the distance it covers is given by the formula. That is s is equals to 4t square plus 3t, where s is the in meter and t is in second. What should be the velocity and the acceleration of the car at t is equals to 20 seconds? Let v be the velocity, a be the acceleration of the car. Therefore, the distance traveled by the car is given by s is equals to 4t square plus 3t. Differentiate with respect to t, the velocity of the car is given by v is equals to ds upon dt, that is a 4 d dt of 4t square plus 3t, that is 8t plus 3 first, and acceleration is given by a is equals to d dt of ds upon dt. That is the derivative of 8t plus 3. That is nothing but the 8. Therefore, a is equals to 8. This is the acceleration. Now put t is equals to 20. We want to find out when the time is 20. Therefore, the velocity of the car t is equals to 20. That is equals to 8 into 20 plus 3. And that is 163 meter per second. Put t is equals to 20 in second. And let's clear that. Its acceleration of the car at t 20 is 8 meter per second square. This is the acceleration. Now in this problem, the acceleration is independent of the time. That is, we get directly its value is independent of the time. Such a motion is said to be uniformly accelerated motion. Very nice. This type of motion. Now the second problem. The displacement of a particle at time t is given by s is equals to 3t cube minus 5t square plus 4t minus 3. Find the time when the acceleration is 14 feet per second square. The velocity and displacement at that time. That is, we have given that is s is equals to 2t cube minus 5t square plus 4t minus 3. This is the first. Now differentiate this with respect to t. Therefore, velocity is ds upon dt, that is a 6t square minus derivative of 5t square. It's a 10t. Derivative of 4t is a 4. Therefore, ds upon dt, that is a velocity, 6t square minus 10t plus 4. This is the velocity. Now to find out the acceleration, now differentiate acceleration. That's the dv upon dt, ddt of 6t square minus 10t plus 4. And that is equals to 12t minus 10. A is equals to 12t minus 10. Therefore, we have given that the acceleration is of 14 feet per second square. Therefore, 14 is equals to 12t minus 10. And evaluate this. That is a 12t is equals to 14 plus 10, which is equals to 24. Therefore, t is equals to 2. We have the value of t is equals to 2. And its velocity, substitute its value. That is 6t square minus 10t plus 4. That is equals to it's a displacement at t is equals to, substitute the t is equals to 2 in the given expression. That is, you will get that is a 2t cube minus 5t square plus 4t minus 3, and you will get that is equals to 1 feet. Hence, the velocity is 8 feet per second and the displacement is 1 foot after the 2 seconds. Now we'll start the exercise 2.1. Find the equation of the tangent and the normals to the curve at the point on it. Y is equals to x square plus 2 e raised to x plus 2 at the point 0, 2. Now differentiate this first equation with respect to x. dy by dx is equals to derivative of x square is a 2x, derivative of e raised to x is e raised to x, and derivative of 2 is 0. Therefore, differentiate this with respect to x. 2x plus 2 e raised to x, dy by dx at the point 0, 4. Put x is equals to 0, that is a 2 into 0 plus 2 into e raised to 0, and e raised to 0 is 1. and that's why you will get the value of m is equals to 2. Therefore, this is the slope of the tangent is m is equals to 2. Therefore, the equation of the tangent by the slope point form y minus y1 is equals to m in bracket x minus x1. Substitute the values. Y minus 4 is equals to 2 in bracket x minus 0. That is y minus 4 is equals to 2x. That is y is equals to 2x plus 4. This is the equation of the tangent. Now the equation of normal, that is y minus y1 is equals to minus 1 upon m in bracket x minus x1. That is y minus 4 is equals to minus, therefore the equation of the normal is 2y minus 8 is equals to minus x. That is x plus 2y minus 8 is equals to 0. This is the equation of the normal. Now again see this here. We'll see the exercise. The first problem, that is equation of the tangent and normal to the curve y is equals to x square plus 2 e raised to x plus 2 at the point 0, 2. Y is equals to x square plus 2 e raised to x plus 2. Now differentiate this with respect to x. First of all, derivative of x square is a 2x, 2 e raised to x, derivative of 2 is 0. dy by dx at the point 0, 4. Put x is equals to 0. That is a 2 into 0 plus 2 into e raised to 0. That is equals to 2. M is equals to 2. Therefore, the slope of the tangent is m is equals to 2. Now the equation of the tangent by the slope point form, that is y minus y1 is equals to m in bracket x minus x1. Y minus 4 is equals to 2 in bracket x minus 0. Y minus 4 is equals to 2x. Therefore, y is equals to 2x plus 4, or it is written as 2x minus y plus 4 is equals to 0. This is the equation of the tangent. Now the equation of the normal, that is y minus y1 is equals to minus 1 upon m in bracket x minus x1. And that is y minus 4 is equals to minus 1 upon 2 in bracket x minus 0. That is a 2y minus 8 is equals to minus x. Therefore, x plus 2y minus 8 is equals to 0. This is the equation of the normal. Now the next is second, x cube plus y cube minus 9xy is equals to 0 at the point 2, 4. Now differentiate this. This is the implicit type, the function. To find out its derivative, we will apply the product rule. Therefore, derivative of x cube is a 3x square plus 3y square into dy by dx minus 9. Derivative of x is 1 into y plus x into derivative of y is a dy by dx. Now collect the terms of the dy by dx. This is implicit type derivative. That is, substitute directly x is equals to 2 and y is equals to 4. Then you will get the value of the dy by dx. That the dy by dx is equals to m, and that is 4 upon 5. Now the equation of the tangent is y minus y1 is equals to m in bracket x minus x1. That is y minus 4 is equals to 4 upon 5 in bracket x minus 2. 5y minus 20 is equals to 4x. If we simplify it, therefore 4x minus 5y plus 12 is equals to 0. This is the equation of the tangent. Now the next is equation of the normal. Y minus y1 is equals to minus 1 upon m in bracket x minus x1. That is y minus 4 is equals to minus 5 upon 4 in bracket x minus 2. That is a 4 in bracket y minus 4 is equals to minus 5 in bracket x minus 2. Now simplify this. That is a 4y minus 16 is equals to minus 5x plus 10. Therefore, 5x plus 4y minus 26 is equals to 0. This is the equation of normal. See this again. This is implicit type of the function x cube, implicit type derivative x cube plus y cube minus 9xy is equals to 0. Derivative of x cube is a 3x square plus 3y square into dy by dx. Now find out that this derivative of xy by with the help of the product rule. That is first 9, derivative of x is 1 into y plus x into dy by dx, that is equals to 0. That's why, that is divide the whole equation by 3, that is x square plus y square into dy by dx minus 3 in bracket y plus x into dy by dx, that is equals to 0. Therefore, slope at the point 2, 4. Put x is equals to 2 and y is equals to 4. That is a 2 square plus 4 square into dy by dx minus 3. That is a 4 plus 2 into dy by dx, that's equals to 0. Now this is a 4 plus 16 into dy by dx minus 12 minus 6 into dy by dx equals to 0. Therefore, 10 into dy by dx is equals to 8. Therefore, dy by dx is equals to m is equals to 8 upon 10. That is a 4 upon 5. Now the equation of the tangent is y minus y1 is equals to m in bracket x minus x1. Y minus 4 is equals to 4 upon 5 in bracket x minus 2. Now after the simplification, you are getting 5y minus 20 is equals to 4x minus 8. This is the equation of the tangent, that is a 4x minus 5y plus 12 is equals to 0. Now the next is equation of the normal, y minus y1 is equals to minus m in bracket x minus x1. Now simplify this, that is a y minus 4 is equals to minus 5 upon 4 in bracket x minus 2. After simplification, you are getting, that is a 4 in bracket y minus 2 is equals to minus 5 in bracket x minus 2. That is a 4y minus 16 is equals to minus 5x plus 10. And that's why equation of the normal is 5x plus 4y minus 26 is equals to 0. This is the equation of the normal. Now the next is problem number 3. X square minus root 3xy plus 2y square is equals to 5 at the point root 3 comma 2. This is again the implicit type derivative, that is a derivative of x square, implicit type function, derivative of x square is a 2x, and again we will apply the product rule for this xy, derivative of y square is a 2y into dy by dx. That is a 2x minus root 3 in bracket, derivative of x is 1 into y plus x into dy by dx, derivative of y square is a 2y into 2, that is derivative of 5 is 0, and again we'll get that's the value. This is the derivative. On normal multiplication is there 2x minus root 3y minus root 3x into dy by dx plus 4y into dy by dx, that's equals to 0. Collect the terms of the dy by dx. That is a dy by dx into 4y minus root 3x is equals to root 3y minus 2x upon 4y minus root 3x. Therefore, dy by dx at the point root 3 comma 2 is put the value. That is a root 3 into 2. The value of y is 2. Value of x is a root 3 upon 4 into 2 minus root 3 into root 3. That's its a derivative. After putting the value, we get the 0. That is nothing but when x-axis. The slope of the tangent is m is that is equals to 0. Now what about the equation of the tangent? That is a y minus y1 is equals to m in bracket x minus x1, and substitute the value. Therefore, you will get y minus 2 is equals to 0 in bracket x minus root 3, that is equals to 0. Therefore, y is equals to 2. This is the equation of the tangent. That is y is equals to 2. This is the y is equals to 2. This is the line which is a parallel to x-axis and its a slope is 0. A very nice problem. This is the equation of the tangent to the given curve. Now the equation of the normal, it's a slope, that is, this is the y-axis, minus 1 upon, that is not defined. This is not defined. Therefore, x is equals to 2. This is the equation of the normal at that point. Again, see this here. This is the curve that we have given. Differentiate derivative of x square is 2x minus root 3 x into y. Apply the product rule. Derivative of x is 1, y is as it is, plus x into dy by dx. 3y square is equals to 5 plus, that is y square. Derivative of y square is a 2y, that is a 2 into 2y into dy by dx, that is equals to 0. Collect the terms of the dy by dx. Therefore, you will get dy by dx is equals to, that is a root 3y minus 2x upon 4y upon root 3x after collecting these terms, and its value at the point root 3 comma 2. That is, put x is equals to root 3 and y is equals to 2. That is a root 3 into 2 minus 2 into root 3. Overall, that's you will get 0 upon 8 minus 6, that is equals to 0. Now the slope of the tangent is m is equals to 0. Therefore, its equation of the tangent is y minus y1 is equals to m in bracket x minus x1. Put the value, that is y minus 2 is equals to 0 in bracket x minus root 3. That is y is equals to 2. This is the equation of the tangent. And this is nothing but the line which is parallel to the x-axis and its slope is 0. Now the equation of the normal, its slope is, that is minus 1 upon 0. That is minus 1 upon 0. It's a not defined, and that is nothing but x is equals to 2. This is the equation of the normal, and which is parallel to the y-axis. And in this way, we have completed the first part of the exercise 2.1. Now we'll see in the next video the remaining all the problems. Till then, goodbye.